Turn on. There it is. Okay, the camera's on. All right. So what is dimensional analysis? Dimensional analysis is nothing more than changing from one unit of measure to another unit of measure. And this is exactly, it is the foundation stone of chemistry. Everything you do in chemistry is going to use the principles that you're going to learn today in dimensional analysis. And if we don't get it all the way done, we'll finish it on Wednesday, because you might have a class. We had it set for 2:45 because 3 o'clock class would interfere, so we'll get done in time for you to do that. So dimensional analysis is based on things that are equal to each other. For example, 12 inches equals 1 foot. 36 inches equals 1 yard. Okay, let's see. Let's go to 3 feet equals 1 yard. 440, so that would be times 4. 0, 16, 17. 1,760 yards equals 1 mile. Okay, those are what we're talking about when we talk about dimensional analysis. So if I have 666 feet and I want to know how many yards it is, in dimensional analysis, your starting one is put over 1, because that's the start, and then it's times whatever your equivalency is. So we're looking for feet to yards. So we're looking right here. 3 feet is equal to 1 yard. Since my feet is on top, we're going to have 3 feet on the bottom, and 1 yard is what goes on top. And notice, your feet and your feet cancel each other out, and 666 times 1 is 666, and 1 times 3 is 3, and so 666 divided by 3 gives me 222 yards. That's all dimensional analysis is. But this is an easy one. Some of them get to be pretty hard. And so this is our American units. And as you know, American units are, everything is always different. And that's why why science doesn't really care for it very much. Because every single thing is different all the time. And so if you look at it, you have a lot of different units make up our system. How about 16 ounces equals 1 pound? 2 cups equals 1 pint. 2 pints equals 1 quart. And 4 quarts equals 1 gallon. So you see how completely different everything is. And there's many, many more of them. 2,000 pounds equals a ton, and so on, and so on, and so on. Whereas the metric system is really, really nice, because your international standard units is what your metric system is. So standard SI is what we call the metric system for standard international units. And so we have meters is a measure of distance, and grams are your measure of weight or mass, and then you have liters are your measure of volume. But the beauty of this system is that all of it is the same. And this is volume in liquid form. Whereas if we have cubic grams or cubic centimeters, then you have volume in a non-liquid form, okay? So that's something you need to make up. Another thing that we deal with is density. And density is equal to mass divided by volume. And of course your time, sometimes it relates to time, and time is the same. Minutes, seconds, hours, minutes, seconds. So that stays the same.
And these are the times they left. Yep. So that's saying, and they're going the same
So these all have abbreviations.
Yep. So they start here.
Your meters are M, your grams are G, your liters are L. Kind of nice.
And he's going 60 miles per hour.
Okay.
And he's going to go.
Now we have abbreviations that work with this. We start at the top, and the largest unit you can have
And Nancy's is going, starting at the same spot, I just put them on different lines.
I think I'm going to give you actually, where did I put it? There you are. Move them over here.
So what we're going to do is they want to know when they're 105.
This is a real handy chart to have.
Sorry, apart, yes.
Show it on the video,
So I'm
okay?
gonna use this one.
So,
what's going to happen is
if we start at the top, it's your biggest amount. In other words, it's like kilometers or miles or something like that. So, your T for terabytes, or tera, is 10 to the 12th. In other words, what this means, if we have 10 to the 12th meters is equal to 1 terabyte. Okay? And a gigabyte is 10 to the 9th. A mega or a megameter or whatever is 10 to the 6th. Kilometer is 10 to the 3rd. And then you go hecto, and hectometer or whatever it would be is 10 to the 2nd. And deca, and that's DA. In other words, DAM would be decameters, DAG would be decagrams, DAL would be decaliters, and that is 10. And then you're down to your unit itself, whatever it is, whether it's meters, liters, or grams. And that is always your one. Now, these are all bigger than a unit. Down below is all smaller than the unit. So, a deci is 10 to the negative 1, and it's just D. And a centa is 10 to the negative 2, and milla is 10 to the negative 3. Now, if you know anything about Latin, deci is always 10, cent is 100, mil is 1,000. So that, it makes sense. And then you've got micro, which is going to be like this, or an MC, and that is 10 to the negative 6. And a nano is N, and it is 10 to the negative 9. And a picometer, or a pico, is a 10 to the negative 12. And you're going to use these definitions, those units, a lot as we work through this kind of thing, which is why I gave you this. Now, a lot of teachers says, oh, well, if I have to move from here to here, all I have to do is count over. Well, that's kind of nice if you're dealing only with that. But that's not what you're going to do in chemistry, which is why I don't teach you just to count up or down. I'm going to actually go through the actual process. So I like to change all of these into what it actually equals. And I've done this for a group already. So here's one for you, and here's one for you. And as you see on that, what I have done is I have actually put it in relationship to meters, on one side and on the other side in relationship to a decimeter and so on. So 1 meter is equal to 10 decimeters. 1 meter is equal to 100 centimeters. 1 meter is equal to 1,000 millimeters. 1 meter is equal to 1 million micrometers. 1 meter is 1 billion, 1 billion nanometers, and 1 meter is 1 trillion picometers. Okay, and then you have 1 decameter is 10 meters. 1 hectometer is 100 meters. 1 kilometer is 1,000 meters. 1 megameter is 1 million meters. 1 gigameter is 1 billion, and then 1 terameter is 1 trillion. Okay? So what that does is it gives you all those relationships. The first page does it for meters, and then the second column uses your scientific notation with it. And then you go to the second page, well, the back side of the first page does it with grams. You turn the page over, and it does it with liters. So I did this because my students were getting confused and just using the term units. They needed it more precise. So I prepared this for every one of you guys. So you can use that as you're going through things.
What I'm going to do, this is 0.8 hours.
Okay, so let's look at some examples of change.
Change this hours per minute. So take that 0.8 times 60. See this?
That's how you get
No, you're fine.
And I fixed some things so you guys could get some good practice at it. I like a lot of practice, okay. So if you look at C, we're looking at 5.6 centimeters is equal to how many millimeters? Well, there are 10 millimeters in 1 centimeter. So that's your equivalency. 10 millimeters is equal to 1 centimeter. So using your equivalency, you have 5.6 centimeters times. And now, centimeter is on top, so my 1 centimeter is going to go on bottom, and 10 millimeters goes on top. And this is going to equal 56 millimeters. Because your centimeters cancel, and 5.6 times 10 is what it would be.
Hi.
Hi. I know this isn't like for physics, but do they have a similar thing?
Do what?
Did they have to read for like physics 203?
Do we have to read for physics 203?
Not that I know of, other than we can try to help you. I helped a student the other day with it.
Okay.
Okay? So you see how that works? It's kind of nice, isn't it?
So we actually...
You can do any equation with the one, knowing that the same as what you have here, your one is here.
Yes.
But we can...
No matter what you get, you can do
Miss
this.
Dora, my boss, she can help you, my supervisor.
Okay.
She can help you, but right now she's busy working with some chemistry students.
Should I add?
Let's look at 1.25
So if you want
liters
to...
Let's see.
is equal to how many cubic centimeters? Okay, there's going to be several things that have to happen here. We're going to have to do more than one translation on this. You're going to have to change liters
So if you want to call back maybe
milliliters.
an hour.
No.
Miss
Let's
Thor
see.
will
You're going
be
to have to,
available.
first of all,
and
we
you
want to
can,
know cubic
talk to her.
centimeters.
Okay.
Okay,
She's
so
the-
here's our deal.
I have not had
1 cc, which is 1 cubic centimeter, is equal to 1
will be
milliliter.
able to help you.
So we're going to have to change our liters to milliliters to find out our cc's. Does that make sense? And so we need to know liters to milliliters. Well, there's 1,000 milliliters is equal to 1 liter.
Okay, sorry about that. That's okay. I think I
So,
got that.
we have 1.25
Nope, that's okay.
liters
So
times
it adds, oh, sorry. No, you're okay.
1 liter on the bottom, 1,000 milliliters on top.
Similar question.
So that's going to equal,
I'm okay with either.
move the decimal 3 places, 125,250 milliliters. And since it's a 1-to-1 times 1 cc over 1 milliliter, milliliters cancel, and you have 1,250 cc's, which is what cubic centimeters are. Questions on that one? Does it make sense? Do you see how you're just going from one to the next to the next? And you can take this home and practice it. The group C is your best one to practice on. Let's look at some of them that might have more than one change going on. Let's look at this one. 42 centimeters per 1 second. And that's number 20 on your list. Okay? So, and we want to know meters per minute. Okay? So we're going to have to translate seconds to minutes, and we're going to have to translate centimeters to meters. Okay? So, you can, doesn't really matter which one you do first. So let's do seconds to minute. There's 60 seconds in 1 minute. So that takes care of your cancel of your seconds and minutes in the denominator, which it needs to be. And now we're going to change our centimeters to meters. There's 100 centimeters in 1 meter. So we're going to have 100 centimeters on the bottom to 1 meter on the top. So we've got both of them to where they need to be. You multiply straight across on top, so you'd have 42 times 60. You multiply straight across on the bottom, which is divided by 100. That's going to be 0, 21, 24, 25, divided by 100, which is a movement of the decimal 2 places. So this is 25.2 meters per
So then we're going to combine these guys, so we get 65 plus, and let's go ahead and subtract that 37.5.
Do you have any questions on that?
Yeah.
So that's 190 minus 37.5.
So does that whole process, you see how you're canceling? Always what's on top, the one that is your dimensional equivalency. If the name's on top, it has to go on the bottom to cancel out. If it's on the bottom, it has to go on top to cancel out.
No, it's fine.
So you end up with where you
It's
need
better
to
that you
go.
understand the process than just going through it.
Okay? And you will be doing this non-stop on chemistry. In fact, if you finished your first chapter, you've already done a little bit of this in the first chapter assignment. Even though you may not have realized what you were doing, that's exactly what you were doing. And you've already had it too in your first chapter. Would this have helped if you'd had this first?
Yeah, I'm not gonna lie. Like, it explained it a little bit, but it wasn't like in depth at all.
Yeah.
Like, this actually,
It
this
never is. It never is. So there's a lot of really cool stuff we can do with dimensional analysis. And you can use your scientific stuff with it too, using your scientific notation. As you can see, there's a lot of zeros in this stuff. And so like this would be 10 to the second power. If you have like a 10 to the negative 12 and a 10 to the 9, it's easier to add those than it is to keep track of all those zeros. So it's really good that we can do it that way. Okay, let's look at some others. And I don't know if your instructor is going to give you this or not, but this is in a dimensional analysis lab that I got from Bob. She's
Love her.
You know her. I do too. But she gave me this last spring and we went through this with the students because it really helped them. And this is more like what you're going to face in chemistry. Okay? So, what we've got here is we've got different people doing different things. I am going to stop this one and start another.